Welcome to science class, my dear students. Today we are going to discuss the topic that's all around us but often goes unnoticed: magnets and electromagnets. So, this is chapter 4 in your science book for class 7. You might not realize it, but magnets play a huge role in our daily lives, from keeping your fridge door shut to helping motor runs. So, let's get started. First, let's look at the definition of magnetism. Do you know what is magnetism? Magnetism is a mysterious force of attraction or repulsion that exists between magnets and certain materials like iron and steel. Now, let me explain this definition. Magnetism is like an invisible natural force of attraction and repulsion. Okay, it is invisible and it happens between magnets and some special materials like iron or steel. Remember, magnets do not attract all materials, they only attract certain materials. Now, how do we know which materials attract and which do not? To understand this, let's look at some examples. For example, take a magnet and bring it close to a paper clip. The clip will stick to the magnet because it is made of steel, a magnetic material. As we already studied in the definition of magnetism, that magnets attract materials like steel and iron. Since the paper clip is made of steel, that's why it is attracted to the magnet. Similarly, when you bring a magnet close to a plastic spoon or other plastic objects, it would not attract them. Why? Because the magnets attract only certain materials, as we studied in the definition of magnetism. Now, do you know that magnets have two special ends called poles? The North Pole and the South Pole. These poles determine how magnets attract and repel each other. So, when the north pole of one magnet is brought close to the south pole of another magnet, a force is created between these two magnets, causing them to pull towards each other. Now, this pulling together is called attraction. When like poles north north or south south are brought close together, then what happens? They repel each other. Now, this is called repulsion. Magnets come into two main types, that is a permanent magnet and electromagnet. What's the difference? Let me explain. A permanent magnet is a piece of iron or steel that has been magnetized so that it keeps its magnetic properties for a long time. Example of permanent magnet is a bar magnet and fridge magnet. So a permanent magnet is a special kind of magnet that stays magnetic all the time. Okay, it remains magnetic all the time. This means it can attract objects like iron, steel, or other magnetic materials without needing any help. Without needing any help means you do not need to add electricity or do anything to make it works. It remains magnetized all the time. It's always ready to attract certain materials. And a permanent magnet is a magnet that stays magnetic without needing any electricity, while an electromagnet is a magnet that works only when electricity current flows through it. Now, next one is electromagnet. So, what is electromagnet? An electromagnet is a magnet created by electricity. Okay, it is a type of magnet that works only when electricity is passed through it, and these magnets are temporarily magnetized. And it is made by wrapping a wire around a piece of iron like a nail. When you connect the wire to a battery, electricity flows through the wire and the iron becomes a magnet. Now, this magnet can attract things like paper clips or nails. The cool thing is that you can turn the magnet on or off by starting or stopping the electricity. So, unlike a permanent magnet, it works only when electricity is flowing. Examples include the magnets used in electric drills and headphones. Now, it's time to test your knowledge with some simple questions. Let's see what you have learned about magnets. Take a moment to think about these questions and we will discuss the answers shortly. So, question number one: what is magnetism? The answer is that magnetism is the force by which a magnet attracts certain material. So this is very simple definition. What is magnetism? Magnetism is the force by which a magnet attracts certain materials. Second question. Explain the difference between permanent magnet and electromagnet. So, a permanent magnet is always magnetic. Okay, it remains magnetic for a long time, while an electromagnet is a magnet only when electricity flows through it. And permanent magnet produces its own magnetic field and does not need electricity to work, while an electromagnetic strength can be turned on, off, or adjusted by controlling the electric current. Examples include for the permanent magnet are bar magnets and refrigerator magnets, and electromagnet example are electric drill and headphones. So this is the main differences between permanent magnet and electromagnet. Now question 3. Give two examples where a permanent magnet might be used. The example are refrigerator doors and bar magnet. So students, an example of a permanent magnet is a bar magnet and the magnet inside a refrigerator door. Okay. You already know about the bar magnet. And now you should know that refrigerator doors have magnets inside them. These magnets are permanent magnets because they always keep their magnetic property. So these two are the examples of permanent magnet, the refrigerator doors and the bar magnet. Give two examples where an electromagnet might be used. So electromagnet might be used in electric drills and crane. Now, inside an electric drill, a coil of wire acts as an electromagnet. So, when current flows through it, the electromagnet interacts with permanent magnets, causing the drill to rotate. Why it's an electromagnet? Because the wire coil only becomes magnetic when electricity flows through it. And the second example is a large crane in a junkyard uses a powerful electromagnet to pick up heavy metal objects like cars or scrap iron. Question 5. Which of these materials would be attracted by a magnet? Copper wire, plastic ruler, iron nail, paper, steel pin, brass button. The material that would be attracted by a magnet are iron nail and steel pin. Magnet attracts iron nail and steel pin. Now, steel pin. Now, why only steel pin and iron nail are attracted towards magnet? Why not other material? This is because we already studied in the definition of magnets that magnets attract materials that is made of certain metals like iron or steel. So iron nail is made of iron, which is a magnetic material, and steel is an alloy that contains iron, making it magnetic. So other materials are not attracted because these all are non-magnetic. So students, do you know why do iron filings stick to the poles of a magnet? It is because when a bar magnet is dipped into iron fillings, the fillings stick mostly to its ends. Why? This happens because the poles are the strongest part of the magnet and the magnetic force is strongest at the poles. When a magnet is hung freely, it lines up with the Earth's magnetic field. Why? Do you know why? When a magnet is hung freely, it lines up with the Earth's magnetic field. It means it attracts to the Earth. It lines up mean it attracts to the Earth. So why this happens? Because the earth itself works like a big magnet with its own magnetic field. It shows how magnets respond to the earth's magnetic force. So our next topic is magnetic field. What is a magnetic field? Do you know about that? A magnetic field is the space around a magnet where magnetic materials experience a force. So a magnetic field is invisible area around a magnet, and it is invisible but can be detected. As shown in the diagram, the curved lines around the magnet represent the magnetic field. The arrows show the direction of the magnetic force from the north pole to the south pole. So where the lines are closer together, okay, where the lines are closer together near the poles, it means the magnetic field is stronger at the poles, the north pole and the south pole. Now detecting magnetic field. So a magnetic field is invisible. Okay, as you already studied that The magnetic field is invisible, but we can detect. How we can detect? It can be detected by using a plotting compass. Okay, as you see in the picture, the plotting compass, the compass needle. So a plotting compass has a tiny magnetic needle that can rotate freely. When placed near a magnet, the needle aligns with the magnetic field. The north end of the needle points along the magnetic field's direction. So this helps us study and understand the shape and direction of magnetic fields around a magnet. Now, these diagrams show the magnetic field patterns produced when unlike poles of two magnets are brought close together. So, what's happening when two unlike poles, north and south, are facing each other? Now, the magnetic field lines from the north pole of one magnet curve and connect to the south pole of the other magnet. The field lines are concentrated between the poles. This indicates attraction between the two magnets. The field is strongest where the lines are close together. The second diagram showing that when like poles of two magnets are brought close together. Now, when like poles of two magnets are brought close together, what's happening? The field lines move away from north pole and toward the south pole. Why? Because the field lines between like poles do not connect because the magnets repel each other. Okay, that's why instead the lines bend away, indicating a region of weak interaction. So students, this is the end of our today's lecture. We will discuss the remaining part of the chapter in the next video. Thank you for watching this video. I hope you understood the lecture. If you found this video helpful, do not forget to like, share and subscribe for more amazing science topics. See you in the next video.